shifting of axes, shifting of origin, you can say, or translation of axes, translation of axes. What it means is, let us say you have got a point in the coordinate system, Cartesian coordinate system. Let us say this is the point and it has got coordinates, let us say x comma y, right? This is x-axis and this is, we know, y-axis. All right, this is something that we know already. Now if this is the point in two-dimensional coordinate system, then what will be this length? This will be the abscissa, right? So it will be x. And what will be this length up to here? This is, we know, equal to y, right? Now if I shift this origin somewhere else without rotating the axis, right? So the axes are not rotated, okay, but the origin is being shifted. So now let us say if I shift the origin to this place, okay, or let me name this new origin as h comma k. So I am shifting this origin which was 0 comma 0 to a new place which is h comma k. So if I look at these distances, this will be h and this will be k, right? So I have now shifted the origin to h comma k and these are my new axes, x and y axes. These are new axes. So the coordinates of this point in terms of new axes, let us say, are capital X comma capital Y. How are these new coordinates related with these old coordinates? This is what shifting of origin or translation of axes is all about. So let us see how these are related. Now these new coordinates are for this new system, right? So what will be this length as per the new system? This here is capital X and this length here is capital Y, right, as per the new system. Now if you see the relation between old coordinates and new coordinates, you will find that if this is small x and this is h and this length is capital X, so the old x coordinate is equal to new x coordinate plus h, right? So the new coordinate x coordinate is equal to old x coordinate minus h, right? This is about shifting of origin. So what will be new y coordinate? New y coordinate will obviously be old y coordinate minus k, right? And what about old y coordinate? Obviously it will be equal to new y coordinate plus k, where h and k are the coordinates of new origin and x, capital X and capital Y are the new coordinates of the point that we were referring to in the old system. Okay, I hope this is clear to you. If I shift the origin from 0 0 to h comma k, if in the old system a point had coordinates x comma y, in the new system this point, the same point P, let us say, let me name this point, the same point P will have coordinates x minus h comma y minus k. Now in this I have not named the new coordinates as capital X or capital Y, right? So if there is a point P, when the origin was at 0 0, it had coordinates x comma y. Now I have shifted the origin to h comma k and now the coordinates of the same point in the new system are x minus h, y minus k. Now we can give it another name like capital X and capital Y. So, and we can use them interchangeably like this. X can be written as x plus h, y can be written as y plus k, and the new coordinates obviously are small x minus h and small y minus k, right? So if there is a curve in a coordinate system and I shift the origin to some new place, and now I need to find the equation of that curve in that new system, right? So what I'll do is I'll simply replace the old coordinates x and y with this expression here, x plus h and y plus k. Let me take a question. I think this will be clear to you. Let us say if the origin is shifted to the point 1 comma negative 2 without the rotation of axes, what do the following equations become, right? So these are the equations in x and y with the origin at 0 0. Now we have shifted the origin to 1 comma negative 2. So the new coordinates, right, will be old coordinate minus h, y, old y minus k. Now what are h and k? In this case h is 1 and k is negative 2. So my new coordinates in terms of capital X and capital Y will be x minus 1 and y will be equal to y minus minus 2, that is plus 2. And in this equation also I'll have these as my new coordinates. So what I am simply going to do here is I will replace this small x with capital X plus 1 and small y with y minus 2 in both the equations, and I'll get the new equations as per the new coordinate system. So let me replace x with capital X plus 1 here. So I'll have twice of x plus 1 squared, that is x square plus 1 plus 2x, then y squared, so it will be equal to y square plus 4 minus 4y minus 4x, so it will be equal to minus 4x plus 1, and then plus 4y, so it will be 4y minus 2, and it is equal to 0. So the new equation will become, now how many capital X square are there? 2x square. How many y squares are there? Y squared is only 1 y square. So now how many x are there? 2 into 2x, that is 4x, minus 4 into x minus 4x, so x will cancel out and there will be no term containing capital X. What about y? This is minus 4y, right? And this is plus 4y. So y will also be not there, right? So y, the terms containing y, capital Y, will get cancelled out. Now what about constant? 2 into 1 is 2, plus 4, 6. Then this will be minus 4, again 2. So, and this will be minus 8. So minus 6 will remain in the end, and it will be equal to 0. So the new equation that I was looking for is 2 capital X square plus y squared is equal to 6. Alright, and this was the first part of this question. This was the equation, right? So this has become 2 capital X square plus y square is equal to 6. Now let us look at this second one. So if I replace this small y with y minus 2, it will be equal to, let me change the color, right? So it will be equal to y squared plus 4 minus 4y. Then there is minus 4x. So it will be equal to minus 4 capital X minus 4. Then there is plus 4y. So it will become plus 4 capital Y minus 8, right? And then there is plus 8 and it is equal to 0. So this 8 will get cancelled, and there is this minus 4y and there is this plus 4y. These will also get cancelled. So what I am left with is y squared. This 4 is also getting cancelled. Y squared minus 4x. Y squared minus 4x is equal to 0. So this is the new equation, or the equation in new coordinate system. See, I shifted the origin to a new place, right? Now I've got completely new rectangular coordinate system with new origin. So this is the equation with new coordinates, right? This was the purpose of this question. All right. So at what point should the origin be shifted if the coordinates of a point 4 comma 5 become minus 3 comma 9? So we know that small x is equal to capital X plus h and small y is equal to capital Y plus k. Now what are these? These are old coordinates x, y, right, with the origin at 0 0, and this h k give me the coordinate of new origin. So what I am going to find is the values of h and k, where old coordinates are 4 comma 5. So in place of this small x I'll place 4, and what is this capital X? It is minus 3. So 4 is equal to minus 3 plus h, so h is equal to 7. What about k? Y originally was 5, then when the origin was shifted it became 9. So where was the origin shifted? What was the y coordinate of the origin, new origin? So 5 minus 9, that is minus 4. So the origin is to be shifted at 7 comma minus 4 for this point to become this. Okay, now that we have studied about shifting of origin, let us study about rotation of axes without shifting the origin, without shifting the origin. In the last article we studied the shifting of origin without rotating the axes. Now we are studying about rotation of axes without shifting the origin. So what I mean is, let us say I've got this coordinate axis, right, where this is x-axis and this is y-axis, and I've got a point, let us say somewhere here, which has got coordinates x comma y in this coordinate system, right? Now the origin is 0 comma 0, but I am rotating the axes now. Okay, and we know by our previous knowledge that this length is obviously small x and this is small y, right? This much we already know. Now let us rotate these axes. So x-axis, let us say, will come here after rotation by angle theta. Okay, so y-axis will shift accordingly, obviously by the same angle here, right? So this is my new x-axis, let us denote it by x dash, and this is my new y-axis, and this is my new coordinate system with the same origin, that is 0 comma 0, right? So if I take, let us say, you keep this in mind that you are free to choose where you take your x-axis, but then you cannot choose your y-axis because y-axis will be at right angle and in anti-clockwise sense, right? So x-axis, if you are taking at x dash, then the y-axis is already fixed that it will go to y dash. Okay, so now think about this point P in terms of these new axes. Let us say the new coordinates of this point in this coordinate system, rotated coordinate system, are x dash comma y dash. So let us see how this x dash y dash is related with this xy. Okay, so let us see what is x dash. If I drop a perpendicular here, because this is how we look at the coordinates, this was also a perpendicular dropped on x-axis, so I am dropping a perpendicular from this point to this new x-axis, right? So what will be this length up to this point? What will be this? This will be x dash, small x dash, right? And what about this length, y dash? Now I've dropped a perpendicular here, so obviously if I can show you, if I draw a line parallel to this new x-axis, so obviously this is y dash, right, which is this length, right? Now that I've shown you the new x dash and new y dash, so let me relate it with the old x and y coordinate. This length was y. Now this angle is theta, this angle is 90 degrees. So what will be this angle? This angle will be 90 minus theta, right? To make the sum of angles of this triangle equal to 180 degrees, this angle will be 90 minus theta. So this angle will also be 90 minus theta. So what will be this angle? This angle will be theta, right? This is 90 minus theta. Let me drop another perpendicular from this point to the old x-axis, right? Now see, this length I already know. If I talk about this length, this I already know is x dash cos of this angle. So it will be equal to x dash cos theta, right? Now if I know this length, I'll be able to relate this old x coordinate with the new coordinates. So what will be this? If I drop a perpendicular here, now I see this is y dash and this angle is theta. So this side is opposite to theta, so it will be equal to y dash sine theta, right? So this length here will be y dash sine theta. Now we know in a triangle, let us say if this is theta and this is r, we have already studied that this opposite side will be r sine theta and this adjacent side will be r cos theta, right? This much you should already know. Now so this length here, this length is y dash sine theta. So what can I say about x, small x? That small x is nothing but x dash cos theta minus y dash sine theta, right? And similarly we can talk about y coordinate, because let me change the color and then it will be more clear to you. This length here is y dash cos theta, right? If this is r, this is theta, then this length here or the adjacent length will be r cos theta. Similarly, if this is y dash, this angle is theta, so this will be y dash cos theta. What about this length here? This is x dash and this angle is theta, so this length is opposite this angle here, so it will be x dash sine theta, right? So this y is equal to x dash sine theta plus y dash cos theta, y dash cos theta. So these are the new coordinates x dash y dash related to the old coordinate x comma y. So let me take a question and then we will see how to use this knowledge. The equation of a curve referred to a given system of axes is this. Find its equation if the axes are rotated through an angle 45 degrees, the origin remaining unchanged. So now we know how to change the coordinates. So I can say that x is equal to x dash cos 45, because the axes are being rotated through an angle 45 degrees. So x dash cos 45, which is 1 by root 2, minus y dash sine 45, that is again 1 by root 2. So what can you say about this? It will be equal to x dash minus y dash divided by root 2. So this is the old x coordinate in terms of new coordinates. Y is equal to x dash sine theta, that is x dash sine 45, which is 1 by root 2, plus y dash cos theta, which is again 1 by root 2. So it is equal to x dash plus y dash upon root 2. Now to find the new equation, I can replace x and y in this equation by these values of x and y in terms of new coordinates. So let me do that. So the new equation will be 3x dash minus y dash divided by root 2 squared plus twice of x into y. So x dash minus y dash by root 2 into x dash plus y dash by root 2 plus 3y squared, that is x dash plus y dash divided by root 2 squared, and it is equal to 10. Now we just need to simplify this and we will have our answer in terms of new coordinates. So it is 3, root 2 squared is 2, so it can be written outside, 3 by 2, and this will be x dash squared plus y dash squared minus twice of x dash y dash. Root 2 into root 2 is 2, so it will be cancelled with this 2, and this is a minus b into a plus b, so I can write it as x dash squared minus y dash squared, then plus root 2 squared is 2, so it is 3 by 2 x dash square plus y dash, x dash plus y dash whole square, so it will be x dash squared plus y dash squared plus twice of x dash y dash, and it is equal to 10. So if you notice, this is 3 by 2, this is 3 by 2, and this is minus 2x dash y dash, this is plus 2x dash y dash, so this can be cancelled here, right? Okay, and this is 3 by 2 x dash squared, this is 3 by 2 x dash squared, so if you add these will be 3x dash squared, and there is another x dash square here, so total 4x dash squared. And what about y dash squared? This is 3 by 2, this is 3 by 2, so total 3 minus 1, so 2y dash squared, and on the right hand side I've got 10. So what you can do is, to further simplify it a little bit, you can write it as 2x dash squared plus y dash squared equal to 5. So this is the new equation that we were looking for. Now before moving ahead, I just wanted to say that we had written the old coordinates in terms of these new coordinates. Similarly, you can write these new coordinates in terms of the old coordinates, right? That process is also very simple. I just don't want you to, memorize these. You can derive this formula very easily there and then. If you can memorize it, then it is even more better, right? So let us see if we can write the coordinates other way around. If I've got these coordinate axes, I rotated these by angle theta. After this, we will study when the origin is shifted and the axes are rotated. Both of these transformations are done at once. Okay, what will be the effect on the coordinates? So this was the new coordinate axes, and this is point P, which in old system has got coordinates x comma y, and in new system it has got coordinates x dash y dash. So this was the length x, and this was small y, right? And in terms of new coordinates, this was y dash, and this length was x dash, right? And I also displayed that if this angle is theta, this angle will also be theta, because this is a perpendicular, right? So if this is theta, this is 90 minus theta, this angle will also be 90 minus theta, so this will be theta, right? Now I want to write x dash in terms of x and y, right? So x dash in terms of x and y. Now let us see. If I draw, or if I drop a perpendicular from this point to this line here, this is 90 degrees, right? So this line will be parallel to this line, right? And this length up to here will be x cos theta, because this is a right angle triangle and this is hypotenuse, this angle is theta, so this will be, adjacent side will be x cos theta. What will be this side? This will be x sin theta, right? This much we already know. How to obtain these? Because in a triangle we know if this is theta, this is r, this is 90 degrees, so this will be r cos theta, and the opposite side will be r sin theta. I have been telling this again and again. So we know that this length is x cos theta. Now what about the remaining length up to here? This length. Now if I can extend this line like this and draw a line parallel to x dash, this x dash, this line is parallel to x dash, right? This angle is theta, this length is y, small y, right? And this angle is 90 degrees because I have drawn it parallel to x dash, and this angle is 90 degrees. So what can you say about this length? This is y, this is theta, so this will be y sin theta. Now if you notice, I can write x dash in terms of x cos theta plus y sin theta, right? Because this is nothing but y sin theta and this is x cos theta. So I have added these to obtain x dash. Similarly, you can find y dash, this, right? What will be y dash? This is y, this is theta, so this entire length up to this point is y cos theta, right? And this length we already know, this length we already know is x sin theta. So what will be y dash? It will be equal to y cos theta minus x sin theta, right? So I have written new coordinates in terms of old coordinates like this: x cos theta plus y sin theta and y cos theta minus x sin theta. And we had already written the old coordinates in terms of the new coordinates: x dash cos theta minus y dash sin theta, x dash sin theta plus y dash cos theta, right? So now it depends on the question how you use these transformations. There can be another transformation where the origin is shifted and the axes are rotated. So let us say the origin is shifted and origin is shifted here and axes are rotated. Okay, by an angle theta. So this is the new origin h comma k. Now what we have learned till now, we can club these two results to obtain the new coordinates of, let us say, this point P. So the new coordinates for this point P, origin, let us say, is shifted to h comma k, right? And the new coordinates will, the old coordinates x will be equal to h plus x dash cos theta minus y dash sin theta, and y will be equal to k x dash sin theta plus y dash cos theta. So I have clubbed the two results and written these coordinates in terms of the new coordinates. New coordinates are x dash y dash and new origin is h comma k. Alright, I hope this article is clear to you.